So as we are talking about the different layers of your OSI reference model, today we will try to discuss the most important layer is the transport layer. So in this transport layer, we try to discuss how the transport layer communication will be established and how it supports to network communication, and whether that communication session is established or not, that will be checked by the transport layer for the establishment of the session between source and the destination, and whether the established communication is a reliable communication channel or not, that will be checked by your transport layer. So this is the basic objective of your transport layer. So we'll see that what are the different characteristics of your transport layer. So as we discussed in the TCP IP soup, that the lower three layers, these lower three layers, or internet layer, data link layer, and physical layer, we say, they try to establish a connection physically. That is, we call point-to-point connection. But whereas the upper layers, like your the internet layer or your network access layer, transport layer or your application layer, they are the process-to-process communication. That means they are logically connected, not physically connected. So this transport layer is responsible for the logical communication between your applications running on a different host. So different applications will be there. It may be your email application, or it may be your multimedia application, it may be your audio application, video application. So there may be different applications. So it is up to the transport layer to establish a connection and support for those applications for different hosts in the network. So in this diagram, if you see that, the transport layer of your different hosts, they logically connected that if there is a Vivo IP connection is there, then Vivo IP TCP will be established. If there is a TCP connection is there, TCP connection will be established from your host to host, like desktop to desktop, or your mobile phone to mobile phone. So the transport layer is the link between the application layer and its lower layer, that is your internet layer, right? That are the responsible for the network transmission. So here the transport layer has no knowledge of the destination host on destination side. So whether that host, what type of host it is, whether the host is the desktop or mobile phone or simply any laptops or any the phone type. So no idea about that type for the sender side transport layer, and the type of media for which the data must travel. That means whether it is the your protocol data unit will go through the copper wire, or it may go with the twisted pair cable or coaxial cable or fiber optics. That's also not part of your TCP. So TCP transport layer, no idea about the what type of media is used for transferring the data and how the data is going through, whether it is going through a predefined route or the dynamically defined route. No idea about how the data will be transferred, in which way it goes. So that the path taken by the data is not known to this, and whether the sender transport layer simply transport the segments into the network but don't bother whether network is congested or not. Okay. So these are few concerns which are out of the boundary of your transport layer. But whereas it provides two different types of services for establishing a communication between your host 1 and host 2, or host 1 to other hosts. One is the connection oriented service, another one is connection less service, we used to say. So connection oriented service, for that it used the protocol, the transmission control protocol. And for connection less service, it used the user datagram protocol. We'll discuss this in details, how the connections are established. So only these two services it provides. So to establish a connection and to check whether that established connection is reliable connection or not. That's all. Okay. So the transport layer's responsibility is, the first one is, it provides the role of your transport layer to just establish the connection. So what is the responsibility then? Role is to establish a connection. Responsibility is, the transport layer has the many responsibilities, such as tracking the individual conversations. Tracking the individual conversation. That means each set of data flowing between a source application and a destination application is known as the conversation. Known as the conversation. So it must to track every individual conversations. So that conversation may be the email conversation or your instant message conversation. It may be the multiple web page conversation. It may be the online video chatting conversation or the streaming conversation. So for every individual conversations, transport layer has to take the responsibility for that. So it is the responsibility of your transport layer to maintain the track these multiple conversations. That one conversation is going in mail way, another conversation is going in instant message way, another conversation is your multiple web pages, video and audio streaming, like that. It must maintain individually. So most networks have the limitations on the amount of data that can be included in a single packet. So it may be your email packet, it may be your instant message packet, or it may be any video streaming or audio streaming packets. So that data must be, after that limitation, because every packet, suppose it is a 32 byte packet, suppose. If you have data more than 32 bytes, in that case, you need to divide the entire data into small pieces which can fit into that 32 bytes. Okay. That means this is another responsibility of your transport layer. So whatever the protocol data unit it gets on sender side from the application layer, that we divide into the small pieces. We call them as your segments. It must divide them into small pieces so that the segmenting the data and reassembling the segments on the destination side. Right? So it is the transport layer's responsibility to divide the application data. It may be your email application or any of these applications. Okay. So it divide the data into the appropriate sized blocks. And we call those blocks as your segments. The segment datagrams. Okay. So depending on the transport layer protocol which is used, it may be your TCP or it may be your UDP. The transport layer blocks are called either segments or your datagrams. Means if it is using the transport layer protocol, TCP protocol, then we call that blocks as your segments. If the connection is established with the UDP, then we call that as your datagrams. Right? So the transport layer using different blocks for each conversation, you can see from in this case. For different blocks, it use the different, whether segment or datagrams will be used for that, based on the connection. If it is, suppose, let us assume that this is for your TCP, so we called it as your segment. If this is your UDP, we call it as your datagrams. Right? So this transport layer divides this data into the smaller blocks, that is segments or your datagrams, so that are easier to manage and transport from your, the sender to your receivers. The sender and the receiver. So then once the big message or the application data is divided into blocks, it may be in segment or it may be in your datagram, when it is dividing, it must keep the sequence of those blocks. Sequence of those blocks. So to keep the sequence of those blocks, that the entire message divided into block 1, block 2, block 3, block 4, like that, it must maintain for what connection purpose it is divided, whether it is divided based on your TCP connection or UDP connection. So for every block it must be identified. So it must add the header field for that block. The header information should be added to every block. Okay, as some are suppose segments, some are datagram, then it must add some additional information in terms of your add the header information that containing the binary data organized into the several fields to each block. You'll see those, what are those fields. So the values in these fields in the header field that enables the various transport layer protocols to perform different functions in managing data communication. So those additional values that identifies whether they are the TCP segment or whether they are the UDP segment datagrams, that will be identified. So this header information is used by the receiving host to reassemble all those blocks together by going through the sequence number of those header fields. That means if the same host, sender host and receiver host, two different connections established, suppose TCP and UDP. So host can receive the segments as well as datagrams. So it must identify which one is the segment and which one is the datagram. So accordingly, it must rearrange or reassemble those blocks to get the original message or original application data. So the transport layer ensures that even with multiple applications running on the device, it may be email application, it may be the instant message application, it may be your audio streaming or video streaming, all applications receive the correct data based on the header field information. So it will have some checksums to check. So what is that? To identify the applications, how it will identify the applications. Okay, whatever the segments or datagrams coming from the host side, I mean the source side, it must identify them, right? So how it will identify them? So it must identify, so it should require the identification number. So to identify, the identification number is required. So we call that identification number as your port number. Port number. So based on this port number value, which is there in the header field, that indicates or that alerts the receiver that this is the electronic mail segment, this is the HTML page segment, this is the internet chat instant message segment. So that is easy for the receiver to identify that. So to pass the data streams to the proper application, the transport layer uses the port number. Am I clear? Okay. So then once the transport layer identifies the port number, then what is the next responsibility? It must do the conversation multiplexing. So in that conversation multiplexing, now what you find? Yeah. So you'll see that the segmentation allows the conversation multiplexing by using the multiple applications can use the network at the same time. So whatever the single connection is established, the same single connection, it may be TCP connection or your UDP connection, will be used for your email purpose or your the instant message purpose or multiple web page purpose, online streaming or your audio streaming purpose. So all those segments are grouped, multiplexed. Okay, multiplexing means what? It takes multiple inputs and gives one output, right? That is multiplexing. So multiple segments means it may be your the email segment, it may be your instant segment, it may be your instant messages segment or your web pages audio streaming, all those will be taken, and the segmentation facilitate the data transport by the lower network layer through the established connection. Okay. If I'm sitting, no problem, right? Okay. Yeah. So in this case, the conversation multiplexing that prevents other communication conversations from occurring at the same time, and also make error recovery and retransmissions and the damaged data is difficult in this. So for that, the error checking can be performed on the data in the segment to determine if the segment was altered during the transmission or not. So for that, the error checking field is required in the header field of your TCP, transport layer header field. So how it will be taken? Then the transport layer, the header field of transport layer looks like this. So in the transport layer, it provides two services. One is TCP service and UDP service. These services supports for different applications. So if the application use the FTP application or HTTP application, SMTP, DNS or FTP application, among them your TCP provides the service to its upper layer, the application layer, for FTP, HTTP, SMTP and DNS, whereas your UDP provides the service for your DNS and the transport layer FTP. Okay, so this IP Internet Protocol is just concerned only with the structure, the address, which address, the IP address of your source and destination addresses, and establish a route from source to destination. But IP does not specify how the delivery or the transport layer packets will be goes. That all these applications, whether they are TCP or UDP, doesn't know to the internet layer protocol IP. It just establish a connection, find a route from source to destination and just forward it. So transport layer that specifies how to transfer the messages. To transfer the messages means what? If it is a TCP segment, suppose TCP says that before transferring the actual data of your FTP or any of these applications, the transport layer triggers or alerts the network internet layer to establish a connection first. To establish a connection means what? Find a path between source and destination. So it is up to the internet layer that whether it follows the static the dynamic routing protocol or the static routing protocols to find a route from source to destination. Okay, so once the route is established, then it will the transport layer alerts the internet layer to start sending the original data. If it is UDP, suppose UDP datagram, UDP don't alert the TCP, the internet protocol, that you establish a connection so that I can transfer the data. No. Whenever UDP is ready, just forward that the UDP datagram to the IP. Don't bother. So the transport layer includes the TCP and UDP protocols. So different applications have different transport reliability requirements. So therefore, TCP IP that provides two transport layer protocols as this. So what are those? What is their functionality? In transmission control protocol, okay, in this layer, what it do? TCP is considered as your reliable connection. Why? Because this is reliable because the full feature transport layer protocol it is. Means this which ensures that all the data arrives at the destination. So when all the data arrives at the destination, if source and your destination, if both are having a dedicated line, which is not used by any other users in the network, suppose the X user, okay, then means all the packets go through the same established connection, so it will guarantee that all the packets are received. If not received any packet because of some errors, then the retransmission will be take place there. So this TCP field, that TCP includes a field in which it ensures that the delivery of your application data, how these fields require some additional processing by sending and receiving the host. So what is that additional processing means? TCP transport is the analogous, like sending packages that are tracked from your source to destination, like UPSC, whatever we use, the postal services, or if you order anything on the the Amazon or anything, you can track that, right, where it is there. So tracking is there means at every port, it's at every hop, its data will be updated in TCP. How it is to provide this reliability and flow control using the basic operations. One is your number and track the data segment which is transmitted. Means what? As we said, when you are dividing the message into blocks, segments, you are going to give this segment number. So with that, which segment is going on now through the established path. So that will be tracking, right? And another one is, once that segment is received by host, it wait for the acknowledgement for that segment, who the sender will wait for the acknowledgement from the receiver. So acknowledgement received data field will be there. This operation will be performed to make it reliable connection. The third one is, if during the transmission, if that segment is, because of internal problems, internal error or external error, if that segment is not received, suppose, then it must be retransmitted by the sender. So that is retransmit any unacknowledged data after certain amount of time. So how much amount of time? It called the round trip time. Round trip time. So in round trip time, it takes the source sending a data packet through a established connection, okay, to your destination. So what is the time taken for traveling from source to your destination, and the time taken by processing that particular packet by your destination, plus the time taken to transfer the acknowledgement back to the acknowledgement back to your sender. This total time, we called it as your round trip time. So the sequence data that might arrive in a wrong order also. The sequence of data that might arrive in wrong order also. That means what? When the entire message is divided into these small messages like message 1, message 2 and message 3, when they are transferring, that the message 1 suppose received, but message 2 during the transmission it dropped, suppose, but after that message 3 is received. So then your destination will give the acknowledgement for only message 1 and message 3, not for message 2. Why? Because when the message 2 or segment 2 is transmitting in the path, if any router is there, if router is busy, router may delay it to forward towards the destination. When it delay, then what happens? The round trip time will exhaust. When round trip time exhausts, your sender assumes that message segment 2 is not received. So segment 2 retransmits. But actually, because of the delay at this router, the segment 2 or message 2 received by the destination 2 times, suppose. Okay. So in that case, what it will do? It will consider only 1, and another duplicate is dropped. So whatever the fastly received segments are there, only for those first come first served type. only for first received message, for those segments, the acknowledgement will be generated by your receiver and send it back. Okay, and the sequence data that might arrive in wrong order, so that will be identified by the sequence number and send data at a efficient rate that is acceptable by your receiver. So here the TCP divides data into the segments. Okay, so these are the additional operations that performed by your transmission control protocol to make sure that it is a reliable connection between source and the destination. Right? So in transmission control protocol, in order to maintain the state of a conversation, means whether it is a email conversation or instant message conversation, web application conversation, to make the state of your conversation and track that information, TCP must first establish a connection between the sender and the receiver, and then this is known as your TCP, is known as your connection oriented protocol. Connection oriented protocol. That means before sending or before tracking the conversation, it is establishing the connection and all the traffic goes through the same connection. So we called it as your connection oriented protocol. Connection oriented protocol. So we'll see this in this case. You can see, so there are 6 packets of segments. So first 3 segments are transmitted, and for those 3 segments, your sender is expecting the acknowledgement and waiting. Once the positive acknowledgement comes, sender sending the remaining segments to the destination. And if you observe in this, all the segments are going through the same path, not different path. It may be in the ISP1, it may be in the ISP2. Alright, so that's why we say it as your connection oriented protocol. So similarly, what will be there inside the TCP header to make the establish a connection oriented communication and then make that communication reliable? In that header field, if you see this, the TCP is a stateful protocol, as it keeps track of the state of your communication sessions. So in this, it is a size of your 20 bytes. TCP header field takes 20 bytes. In that 20 bytes, it used the 16 bits used for your port numbers, the source port number, and 16 bits used for your destination port numbers. So why these port numbers are used? To identify the applications. For different applications, different port numbers are used. For email, it may be port number 110. For suppose your what you call the audio streaming or video streaming, it may use some 550 or 553 protocol port numbers. So based on these port numbers, it alerts the receiver which type of application it is. So that's why we are saying that the TCP connection establish a logical connection, not physical connection. Okay. So to track the state of a session, the TCP records which the information it has sent and which information it has the acknowledged. Means what? Once your entire message is divided into your segments, segment 1, your segment 2, your segment 3, like that. Suppose segment N, it keeps information of every segment, that if first segment is transmitted, it keep track of which segment is now transmitted. It is segment 1. So it waits, the host sender side waits the acknowledgement of your segment 1. Once it is received, then it transfer the next segment. So here multiple segments can also be transmitted. So it keeps that S1, S2 and S3 are transmitted, and it will wait for the acknowledgement of these segments. Once these segments received, then it go on sending remaining three segments or two segments. So that's why we say it is a stateful protocol which keeps track of which one is sent and which one is and for those sended segments whether received the acknowledgement or not. It may be positive or negative acknowledgement. Okay, so this stateful sessions begins with the session establishment, that is the connection is established first. So then the TCP segments add this 20 bytes, that is 160 bits of your overhead when encapsulating the application data with the header field of your TCP. So what will be there? It add the source port number and inform the destination, use the same source port number, sequence number of your segments, and how many segments are transmitted and how many segments are get the positive acknowledgement. So for that 32 bits are used, and it also gives the header length. For TCP header length is different compared to your UDP header length. So it informs the header length to synchronize with this source and destination. If the header length is unknown, then some bits of your TCP header may mix with the IP header, and it use the received. Some reserved bits are there for the special communication purpose, and the control bits will be there to control the congestion. And the sliding window protocol, the window will be used. That this window is basically used first send one segment. If they get the positive acknowledgement, then you try to send the 2 segments. If you get positive acknowledgement, you try to send the 4 segments and go on the linear, the exponential way. And at some point, suppose the number of segments sent, n number of segments sent, but it got only some n divided by n acknowledgements, then your sender comes to know that, okay, I'm sending more segments than the capacity of your bandwidth, your physical layer. So then you try to reduce the window size. So that will keep track of what is the window size of that. Okay. So in this, the most important one is the source port. As said, the 16-bit source port is used to identify the source application, and destination port is used to identify the destination applications. So different applications. For sequence numbers which are used for assembling purpose or reassembling on the destination side. Acknowledgements to know whether the packet is received correctly or not. So these are, and we have the checksum field. So this checksum field is used for your error checking of your segment header. While transferring, there may be the chance of some bits may be corrupted. So then it will check the header field whether that packet is correct or not, or whether that segment is correct or not. Okay. So then another protocol of your transport layer is your UDP. It is completely reverse, or the inverse to your TCP. That means UDP is the simple transport layer protocol than your TCP. Why? Because it does not provide any reliable and the flow control. That means what? Whenever the sender side application, it may be your DNS, it may be your the TFTP, then those datagrams are simply hand over to the lower layer on sender side, that is network layer. You don't bother whether network is busy or idle, or whether connection is established or not. So it don't bother about that. So that means the sender and receiver's UDP process do not have the manage reliability or flow control. So your UDP is a connectionless protocol. The connection is not established. It simply starts sending the packets. Means the sender starts sending the packets of your UDP. So the UDP, when there is no reliability, then there are chances of the packets may be dropped by the intermediate host. So in this case, retransmissions are more, because if I am trying to send more packets to you, and if you are unable to process those many number of packets, if you are an intermediate device, now I am the host and he is the destination, and the connection is established through you. If I send more packets, if you are unable to process those packets because you are busy with another user's packet, then you may slow down or you may drop packets, because I didn't inform you that I want a connection. I'm simply handovering you. So you may respond to that or not. If you respond, okay. If you are not responding, means my packets will be dropped by you. So retransmission will take place there. So the UDP is also known as your stateless protocol, because it is not maintaining which packets are which segments datagrams are transmitted, and for those datagrams whether acknowledgements are received or not. So that is the UDP, which is also known as your best effort delivery. Means it is also known as the best effort delivery protocol, because there is no acknowledgement that the data is received at the destination or not, because it don't maintain any state information. So UDP is like placing a regular non-registered letter in the mailbox. So the sender of the letter is not aware of the availability of your receiver to receive the letters. So you can see here, the sender simply try to send the files through the internet, but no connection will be established. Whether those are received or not, it doesn't bother by that. So here, if you observe in this case, which application is used? TFT. So TFT application or DNS application of your sender side or receiver side, they use the UDP connection rather than TCP connection. Like your email service or other services, they use the TCP connection. So is it possible you to track that your email which is you send is received by the receiver? It is possible. If you in your mail, there is a track option will be there in mail setting. If you go there and in the track information, if you put any simple dot which is like invisible type, so where your receiver cannot notice that the dot is there in that mail. But as soon as they open their inbox mail of your mail, then it will alert you that the receiver received the mail and read the mail. If it is a UDP connection, not possible. So in UDP header, what is there? It uses only how many bytes? 8 bytes, whereas TCP used 20 bytes. So that's why the header size is different. Okay. So UDP, it is a stateless protocol. So it only simply uses the source port number and destination port numbers. Means what? Like whether it is a DNS application or your TFTP application. For that, it uses the protocol. And the same thing informed by your destination side. And the length of your header, the header length and the checksum of this letterhead. So after that, the application data is size variable. So that is the only. If it is a stateful protocol, then it must add the other bytes. What are those sequence numbers, acknowledgement numbers, urgent bits, Windows bits, checksum bits, header length bits? All those are required. For UDP is a stateless, so it simply holds only the source port number and the destination port numbers. Yeah.
So how does it handle reconstruction at the destination if there's no sequence number?
Yeah, that is what. In this case, that is the problem. That's why these are used for only streaming purpose, basically, to FTP and those. So receiver side, they simply used whatever bytes are coming based on this length of that. They try to communicate, try to arrange those datagrams in the same sequence, received sequence. So in that case, it will check with the checksum whether they are in the same sequence or not. If not, then because in this case, if you remember, as says that in the previous slide, it won't provide any acknowledgement. It is, so in this case means what? If I am a sender, I am requesting a page like www.cisco.com. It is a DNS. So for DNS application, the transport layer provides UDP connection. Correct? So when you are sending www.cisco.com, so it goes to Cisco server. So Cisco server, if able to reply, so how it will reply? It will open the web page. If not reply, then you will find some errors that 404 page not found error. So this is basically for client server communication. So this UDP connection is basically used for client server like TFTP and your DNS. For all other acknowledgements, you use the TCP. If you don't need the acknowledgement connection, then you go with the UDP. If you need the acknowledgement connection, then it must be TCP connection. Yeah. So in the source port number, as just explained, the checksums which are used for error checking of your datagram header and the data. Okay. So then comes to the another pair of your transport layer is your socket pairs. So in this socket pair, the source and destination ports, we talk about these ports later, which are placed within this segment. So segment means your TCP connection. Okay. The source and destination ports, they are placed in the segment. So then the segments are then encapsulated with the IP packet because your segment hand over to the lower layer or sender side. That is internet layer. Now this IP packet contains the IP addresses of source and destination. What are those? The IP v4 address of source, IP v4 source of your destination IP address. Right? So TCP provides port numbers that is encapsulated with the IP header. IP header provides the IP addresses, source and destination IP address. Then the combination of your source IP address and the port number. The combination of source IP address and your port number or the destination IP address or destination port number is known as socket. That means if source IP address is 192.168.1.15 and port number is suppose 22 port number. So when you combine these two, it will be known as your socket. So we call this as socket pairing. So it is same on destination side or source side. Destination side means for acknowledgement, these two are combined. Sender side for transmitting the segments. So sockets enable the multiple processes that is running on the client to establish, to distinguish themselves from each other. So the source port number acts as the return address for the requesting application. So the transport layer keeps track of this port number, whether the acknowledgement for the same port number or different port number is there. So it keeps tracks of that port number and the application that initiated to request a when the response is returned. So this we call the socket pairs. So in this socket pair, what will be there? As we said, suppose if you have the sender and the receiver. Sender is a client and receiver is the server, suppose. On sender side, the FTP client source port number, the port number is 1303 is used for your FTP, suppose, port number. And for web client source port number for web pages. For web pages, the port number is suppose 1099. Okay. Then this 1305 and 1099, they both are going through the network. So here it is, when you are doing the socketing, it will use the FTP and the web connection. So how it will be done? So simultaneously requesting this, the FTP as well as the web port or the web services from this destination server, then the FTP request that generated by the PC or your host, that includes the layer 2. Of layer 2 means you are going to include the MAC address of that, the Ethernet address, and the layer 3 protocol, that is your IP address. So the request also identifies what is the port numbers of your FTP server and your web server. So by identifying these FTP services on the port, suppose the 21 or your 80 for your web applications, the host also has requested the web page from this server in this case, right? So based on these port numbers, it is the source port number for web page. This is the destination port number, which is the server is responding in terms of web pages. Okay. So then it is using the source port number, the 1099, and the destination port number, that is port number identifying the web service as your the web pages. So the socket is used to identify the server and service being requested by the client. So a client socket with the 1099 that represent the source port number, that might be your the socket will be looks like your the IP address is the combined with this port number 1099, that becomes the socket number. So this combination of your IP address and your port number gives the socket. So the socket on a web server might be given with this IP address and its port number 80. Okay. So these together, these two sockets that combine two from a socket pair. So when combining these all, it will give you a socket pair. So in transport layer, how the sessions are established then? Okay, how the sessions are established. So as we said, in transport layer you are having the TCP connection and UDP connection, that connection oriented sessions and connection-less sessions. So how these sessions are established then? So we'll see this TCP, the server process. In this TCP server process, each application process which is running on this server is configured to the port numbers. So the port number is either automatically assigned or configured manually by the administrator. So the individual server that cannot have two service which is assigned to the same port number. Like if you have the port number 80 is for your HTTP not for HTTP and your HTTPS. For HTTPS, it use the another port number like 443, like that. Different port numbers are used. So the host running on web server application and a file transfer application cannot have the same port numbers is one. So there can be many ports open simultaneously on a server, one for each active server application. It may be one for your the web application, one for your email, one for your FTP, one for your HTTP. For different, more simultaneously, it can open more port numbers. Port numbers nothing but the gate to get into. So the TCP server process, it is a client sending a TCP request to establish a connection. Okay, so in that the TCP server process for establishing the session is any client, suppose client 1 is requesting a the web page. So that web page is in the form of your HTTP request, hypertext transfer protocol, and in that request it is having its source port number is giving this source port number. I said this source port number can assign dynamically or statically. Okay, and the destination port number. This destination port number is a specified or reserved port number for your HTTP. Right, and your client 2 is sending another request for different application, that is your SMTP request, and the port number, source port number is given randomly, and the SMTP, it holds the port number 25, reserved port. So when these two requests comes from the different clients, okay, so that is client 2 is requesting, client 1 is requesting the web service, and client 2 is requesting the email service, SMTP, the short, the mail transfer protocol it is. So email service at the same time. Then how it establishes the connection? Upon receiving these requests, the server identifies one request is on port number 80, another request is on port number 25. So in that case, it can identify both the ports are open and it can provide service to both the clients simultaneously. So the request at the destination ports, suppose the client 1 requesting the web service using the well-known the destination port number of your 80, and your client 2 is requesting an email service with well-known or reserved port number of your 25 for the SMTP. So use this well-known port numbers as the destination ports, so that your destination that can be get allowed inside your server to process it. If instead of 25 for this SMTP, the result port number, if it gives suppose 80, the 80 port number is busy with this client 1, so this port number, whatever this request is there, that request will be dropped by your servers. So you will get the page is not found. Okay. So the request source ports, then the client requests the dynamically generate the source port numbers as said. So in this case, the source is dynamically generating this port numbers, but destination port number should be unique. It must be well known. So based on those port numbers, it responds, the destination responds based on those port numbers. So when the server responds to this client request, client 1 or your client 2, then it reverses the destination and source port of the initial request. So you can notice that here the server responds to the web request in the response, the HTTP response having the source port number 80 and the destination port number which is provided by source only. Okay. So in TCP's, the response of your source port number again, then the source port is the server's response, is the original destination port in the initial request part, which is requested by your source. So then how to establish this session establishment connection? So in this case, if you see that we got to establish a TCP connection, it uses a 3 handshaking process. In 3-way handshaking, that validate that the destination host is available to the communication. So first step, what it do? The sender sends the TCP connection establishment for synchronization purpose. It send the request TCP connection establishment connection request. So for that request, it gives the sequence number and the time also. So to the sync packet or the segment, that initiate the client request a client server communication session with the service. So upon receiving this synchronization segment along with the segment numbers, if your receiver is free, the receiver will try to respond to that by giving the acknowledgement packet. For that the request, the acknowledgement will be generated. So the server acknowledge the client to the client to server communication session and request a server to client communication session, whether this acknowledgement is received or not. First, it send a request, then the receiver gives the acknowledgement, and once the acknowledgement taken by the B sends the acknowledgement response and sync request to your A for synchronization. In the third step, the initial client acknowledges the server to client communication session that established a connection. Then once for this acknowledgement, once your the sender gives the acknowledgement, then the connection will be established. So it is step 1, 2 and 3. So we call that TCP connection establishment is a 3-way handshaking process. So when the session terminates, then so to close a connection, same like your connection establishment, to close a connection or to finish a connection, a finish control flag must be set in the segment header to finish the connection. So to send each one-way TCP session, a 2-way handshake are consisting of this finishing segment and acknowledgement segment is used. So therefore, to terminate a single conversation supported by your TCP, 4 exchanges are needed to both the sessions. 4 exchanges are needed. One is to one-way the TCP session, 2-way TCP session, and consisting of your FTP. So the term client and server are used as a reference for simplicity, but it will any of 2 hosts that can have an open session can initiate the termination process also. Okay. So this is in session termination. As said, in the header field it must include the finish session. So when the client has no more data to send, then it will send the finish session segment. And for that, your the server respond with the acknowledgement. Okay, B sends the acknowledgement for that finish to terminate the session. And then for this finish, in the third step, the server sends the finish to the client to termination. Means it is a 2-way connection establishment, right? So it is requesting receiver is requesting to the sender that finish the connection which is established between us. And for that, your sender will respond with acknowledgement. Then the connection will be terminated between your client A and your client B or client to server. So this TCP handshake analysis, it gives the functionality that establishes that the destination device is present in the network or not, and it verifies that the destination device has an active service. So if I send any request, I will get the response, and the destination device that the source client intended to establish a communication. So by this three-way handshaking analysis, it will give this information. So in three-way handshaking of your TCP connection, which use the 20 bytes, it will use these control bits, 6 bits for your control. So 6 bits means what? How can you represent? 6 bits means if 2 to the power of 6, how many, the combination services that it can provide. Okay. So these control bits are used for your urgent purpose, for your acknowledgement purpose, for your sequence purpose, your push and reset the connection purpose, synchronize the sequence number used in the connection, and your finish the connection purpose. These control bits are used in three-way handshaking. What are those? One is your urgent, another one is for acknowledgements, your push function, your reset function connection when the error or timeout occurs, and your synchronization of your sequence numbers, and your finish the connection or terminate the connections. Okay, so let me just play a video for you so that you can understand that.
I have some screenshots of a Wireshark packet capture that shows the process of a TCP three-way handshake and the termination of a TCP conversation. Let's analyze these screenshots to get an idea of how it's working. TCP is a connection-oriented protocol, meaning an end-to-end connection needs to be established first before data can be sent or received. The TCP three-way handshake initiates that connection. When the connection finally needs to be terminated, for instance, let's say it's a connection to a web server and you close the web browser, the connection is terminated with two-way handshakes. A TCP three-way handshake involves 3 steps: a SYN and an ACK, and an ACK.